Okay, time for a little video on TinkerCAD and importing different objects into Bambu Studio. Uh, I've got a little mock-up that I've made here, a couple different things, a couple different colors. For example, let's hide these real quick, we don't need them. I've got a couple of different shapes here, a couple different colors. They are free-floating. Nothing special going on here. These are all individual objects, nothing is grouped. That doesn't really matter. Grouping can make life easier, but it's not necessary. So what I'm going to do is I'm going to start off by just grabbing everything, telling it export. I'm going to do an STL and just call it all. I'm then going to grab just my red ones, export them, call it red. I'm going to, click the wrong button. I'm going to grab my green ones, export them, STL, call it green. And then my blue ones, export, STL, blue. Now, before we move on from there, I'm going to unhide the text examples I had, and we'll go ahead and get rid of this stuff because we don't need it anymore. So I've got two examples here, and as I scroll around, you can see that one is on the surface and one is buried inside of the other. Use case here, maybe I want to do a color swap at layer and just have the green and red print in a different color than the base beneath it. The embedded text would be useful if I'm printing face down, or you could print face up if you want and just have it flush. Both very, very common, useful things. So for my surface test, I'm going to grab my gray block and I'm going to call this surface gray. And I'm going to grab my red text and tell it export STL red text. Of course, this being a little bit more of a intense model, it takes it a second to render. And we'll export our little border. Surface green. And I messed up. Red text needs to be surface red. Oops. Surface red and surface green. So let me fix that. Okay, so we have our surface model exported. Cool, I'm going to hide those. That leaves our embedded text. I'm going to do this two different ways to show off two different things that can happen. One, if I just grab the entire thing and export all together. I'm just going to call this embed all. I can then grab my red, export that, STL, embed red, grab my green, export, STL, embed green, and we'll grab the gray, export, STL, embed gray. Now, what I'm going to do before we move on, I'm going to do this one more time, but first, I'm going to grab my red and my green. I'm going to duplicate them. Just Control D, there's a icon up here for it somewhere, I don't know where it is, and then turn it into a whole. Then I'm going to add the gray block to it and group these items. By doing that, I no longer have that clipping, that artifacting that was going on, because I've cut out the shape of the border in the text. If I grab these and pull them up, I've embossed it or cut it or whatever you want to call it. I've taken that material out of the gray block. So now if I export my embed gray, but as we'll call it, I don't know, embed gray cut. So I got a whole bunch of files now. If you've thrown power tools in, you can get the previews, which is pretty nice. I'm going to pull up Bambu Studio, and we're going to start off with that shapes all. This comes in as a single assembly. If I go look in my objects view, it's just a single file. I have the option to cut it into objects and parts. If I choose to cut this into, well, first of all, hang on, let me step back. If I want to color this, I can right-click on it and change filament and make it green, but it's the entire object. I can choose to use the painting tool, and I can do fill, which will do by face. So depending on your fill angle, you can do one face at a time. Okay. You can use the sphere tool to kind of cut some depth into it, but none of that's going to make this, like if I can't make this entire sphere one color, if I don't think at least. Let me prove myself wrong here real quick. If I try and make that whole thing gray, I believe it's just going to be gray on the outside and then still green on the inside. So let's slice it and see what happens. I've got, and I'm just going to turn off my prime tower to get it out of the background. We don't need to worry about seeing that in this demo. Let's see what we have inside that gray cylinder. I honestly don't remember. Oh, hey, it made it all gray. Cool. So that did make that object by painting all of its exterior faces gray. It made that object gray. You can see how the red cuts into the cube here. And I don't think the blue will. It'll just be, yeah, a couple layers on top. That can have an effect if you're working with translucent materials, like if you're working with a thin layer of white and you're trying to put some black text on it or something. If it were to try and cut through like that red did, that will show up fairly significantly. So by using the painting tool, you really don't have control over the depth of how far that color goes. It does it based on geometry, and you're just kind of at the whims of the software as to how it's going to do that. So working with my everything file, if I split this into objects, well, what just happened? Where'd they go? They fell. This is still one object because they were all touching. These are now separate objects because they were not touching, because they were floating in free space. They have become their own individual objects. Okay, cool. That doesn't really help though, because if I wanted to be able to address these individually, now they've lost their positioning data. I can't really work with that. And since I've already split it, I can't split it any further. I can't break this into its inherent parts and objects. The options don't exist. So you can only cut an object once, if I'm not mistaken, at least from an STL. So if I undo all of that, put that back together, this becomes a frustrating proposition to try and control in more detail. So to do this better, I'm going to go ahead and delete that. I'm going to go back and I'm going to grab my blue, my green, my red. I'm going to bring those in all at once. By selecting all three and dragging them in at once, it asks me, do I want to load these as a single object with multiple parts? Yes, I do. Just like before, I have one object, but that object is an assembly. It contains the three items inside of it that made up that item. This is great, because if I wanted to make my blue again, all I have to do is right-click and come down and choose my blue filament. Same thing for my green. I can make that green, and then when I go to slice this, those objects will be solid in those colors. Because it's choosing that it will directly print each one of those objects, each one of those three STLs, in those filaments. Now, I don't know. Let's find out. Can I break that into its parent objects? I cannot, but I can break it into parts. Doing that, they've kept their position data. So I believe they do, yeah, because they're still a part of the same assembly. That's pretty cool. Now I have even more granular control. If I wanted to make this one gray, oh, no, wrong button. Sorry. If I want to make this one gray, I can make it gray. It's no longer part of the same blue STL. It's blue 1 and blue 2. Okay. Parts give you pretty cool options. So this one sees the 2. Okay, I can break that up. I do have the option to break this into its parent object, essentially unassembling it. So now I have my blue 1 and my blue 2. Well, blue 1 has no geometry anymore, so it fell to the floor. If I were to come in and break apart into parts my green, well, I've managed to preserve where those things are, and I can move them individually if I want by selecting one out of the object list, going to move, and moving it around. As part of an assembly where they are items underneath an item, they maintain their individual positioning. As soon as I break this into objects, though, now they are separate from each other, and they automatically flop to the floor. So depending on what you're trying to print and what you've put together, generally speaking, you want things to be where you put them. So I'm just going to delete all of that, and we're going to go back and look at the text. Because I think this is a more real-world example, and I think it helps it exemplify it some. If I grab the embed all, remember this was the one that I just selected everything and pulled it in at once. That's just a red block. That's not very useful. And I want to say, if I'm not mistaken, if I come into my painting tool, I can't see the individual things that are in here. It's all just a red block. I can't select anything. I can't break this into objects or parts, because as far as TinkerCAD was concerned when it exported it, it's just a block. So not very useful. So getting around that, exporting things separately, let's go ahead and first look at the surface ones that we did. Again, I'm selecting all three at once, dragging them over. Get the same warning. Do you want to make it an object with multiple parts? Yes, I do. Here's my surface text. Now, because I gave myself some hints when I exported them, I know I want to make this one green, and I want to make this one gray. So now I have exactly what I had in TinkerCAD. If I go to slice this, I should see exactly what I expect, that the green item will be fully green, the red will be fully red, and they are. Now, how could this be different? If I had taken everything here, and let's just make it all gray, and I had used the painting tool. So I come into painting, and I grab red because I want to make my text red, so I start clicking on my text and finding all of my faces, which takes forever to click everything, but you can get there eventually, and this is not going to be complete because you have to like look from the other side, make sure you found all of those, because look, we missed the inside of the E. Okay, so we've got ace written out. I've lost my view. There we go. Those will probably be solid red because of their size. Let's find out. Yep, they are solid red. That's good. Depending on the size of the thing, like if I tried to make my, let's try and make the backdrop for that blue. So I go back into painting, say blue, and I want that face blue. Cool. That's got some nice contrast. Okay, cool. When I go to slice that, it's going to be like 2 layers maybe. And on top of that, the blue is shining through. It's coming through right here. That's not great. I don't want that. So if I scroll down and look at that in the preview, I get 3 layers of blue. 3 layers is usually enough to mask whatever colors are beneath. Is that 4? 1, 2, 3. 1, 2, 3, 4. Yeah, just 3. I get 1 layer of gray in my text before it turns red. You don't have great control by using the painting tool. I mean, you can get in there and play with it and get more specific with it. Like, it's just frustrating in my opinion. So doing it by object, saying I want my green to be green, I want my red to be red. I still have that blue in there, and I'm still going to have that blue line right here because of the way that painted. That's a condition because of the way this green item is. Not a whole heck of a lot we can do with that in this scenario. It'll be different in the embedded text, though. This would work. I could turn on ironing, make that text super smooth because it's elevated. It won't blur with the blue. You can do a lot of cool stuff like this. Name tags, things like that, they work great in this way. It's also a lot faster and a lot safer than doing face-up in same layer text. You can get color bleed as the nozzle moves around, dragging filament from one color to the other and fusing it together. It doesn't always look so good. So having those 3 items here actually let me color them the way I wanted to. Now, I can't really do too much else here. I could cut this into parts if I wanted. And now I have my individual letters. Just kind of assigns them random numbers. So if I wanted to make the F green, for example, I can do that. And now it's going to be a solid green. Much easier than using the paintbrush tool for this. Highly, highly recommend exporting individual STLs for those colors. So that was the surface. And I cannot drag a select, sorry about that. So we're just going to delete all of that, and we're going to look at the embedded text now. For the embedded text, we looked at embed all and saw that that didn't do us any good. I'm next going to grab the uncut, just the regular embedded gray, which is just that block. Everything is buried inside of it, right? Or I'm sorry, there's nothing there. It's just a gray block. I'm going to grab that. I'm going to grab embed gray, and I'm going to grab embed green. Drag those in together. Yes, embed, or bring them in as a single part. So now you can just barely make out there's a little bit of a line there. If I slice this as it is, it's just going to print me a block. Nothing special, just a block, because that's all it is. If I go back and go back to prepare, sorry, make my green text green, make my gray block gray. How this gets handled is kind of up to the slicer. It should say, oh, well, you've got red and you've got... It didn't even do the green at all. Look at that. It decided not to do it. You're giving the slicer control in that case, because it's trying to decide which object gets priority. And I want to say with the most recent version, you have an option with Boolean somewhere to change which one has priority. I haven't played with that yet. Doing mesh booleans, they've improved that to try and give priority to which one goes first. I haven't played enough with it to be honest. We're solving that problem in CAD to begin with, though. So the use case on this again is if you want to print face down. I think that's really the best use case for this. So I'm going to flip this thing over, slice it again, and we're going to look at it from the bottom. Great. If you're printing this on a textured bed or a PEA sheet or a PEI sheet, that would be nice and smooth. There's 100 different options I would change to make that look better, but we're not getting into that right now. If I look at it from a view where we can actually see what's going on, I can look down at it. We can see where it starts to print those. And here's the fun thing. When I made that model, it was 2 millimeters thick. The text was 2 millimeters thick. And if you look here, I'm 2 millimeters up. If this was just text added through Bambu Studio, which we'll do on the top side of this in a second, you can choose the depth there as well. Depending on how deep you want it to be, usually 3-4 layers is sufficient to mask colors behind it. But getting it centered, getting it lined up, it's a real pain. Sometimes the fonts you want to use don't load into Bambu Studio properly. Getting custom fonts to show up is never fun. So like if I come in here to do text, see I've got like a non-standard there, but the one I want to use, I've tried several different times to load. It refuses to load. It's a TTF font. It just doesn't work. So if I want to do this, say my text is too thick and I want to embed it 2 millimeters, and I'm just going to call this Studio. Well, I can't really see it. Probably because I have it embedded 2 millimeters deep. Should show, it didn't show up. Where'd my text go? Let's try that again. Let's embed it 1.8. Maybe that was it. Maybe it was too far down. Studio. Nope, it's just not showing up. Oh, there it is. Showed up on the side. It's not showing up on the bottom for some reason, or on the top. Trying to show up on the... No? Okay. Surface off. There we go. Had to do a surface. Okay. So let's say I want to embed that by 2. Let's see if that'll actually do what I want it to do. Well, that looks like it's on the surface. It doesn't look like it embedded at all. You could always move it. Move it down. Can I tell it 2 there? No, that didn't work. Oh, wait, Y of 2. Is that going to be there now? Hey, there we go. But you can see how it's frustrating to get it where you might want it to be. There's not really great ways to try and line it up the way they do. The X and Y on this, you can sometimes get it to be lined up roughly where you want it. Let's see, that doesn't make sense. 295 was on the surface. Three would be on the surface, I guess. Where it's getting 3 from, I mean, that's a 10 millimeter tall block with a 2 millimeter text, and yet Z of 3. So from the middle, it moves up by 3. The positioning is weird. I don't like it, to be entirely honest. I mean, I've managed to get it centered and on the surface, but it took a lot of playing, guessing how the numbers work. That, again, it's 2 millimeters tall, and it's looking at this 10 millimeter object and saying, move it up 3 millimeters, so then my 2 millimeters of text is on the surface. Okay. Weird, but it worked. I got it in place, and it is centered. So you can do that. I just find it easier to do that in CAD and set it up the way you want. And I still don't have my green outline. It's not there. It's definitely there in the preview. We know it's there. We can see it. We can select it. Maybe it needs to be lower or higher. No, it's there, but it's not choosing to show it to me in the preview. It's not going to print it. That green will not be there. I have no usage of my green filament. That's why I cut things out. That was the whole point of the embedding example. We're going to delete this, go back to, and instead of using gray, we're going to use the one we cut. If I bring these over now, do the same thing, say yes, multiple parts. Now I can say I want my green to be green, and I want my gray to be gray. When I slice this, it absolutely will have everything there. It's the way we put it together. If I come in and grab my green and red and move them up, definitely see that we have that cut out. Now, the pro and con to this, while this absolutely ensures everything is there, you may end up having to fight where your walls go. And this is why you have to make sure it is precisely cut. If you had a gap in between the gray and the red, like you would move the things around after you would cut them out, or you would resize things without resizing the cut as well, you would have a gap in your print. So you have to be very careful when you're putting that together to make sure that you absolutely have gone through and ensured that the borders of whatever holes you cut are exactly the borders of the item you're putting in. So just like there's difficulty in Studio with getting things where you want them, there's difficulty in CAD trying to make sure that you have that hole cut precisely. Again, the super easy secret little trick on that, I am just undoing what I had done before. If I grab my red and my green and move them up, you can see it's not cut. I duplicated it, Control D. It's still selected. I haven't clicked anywhere. Turn that into a hole, then add the model I'm cutting into and group them. Make all of your design, your change, get everything the way you want. Do that operation, and you'll end up with exactly what you were looking for in Bambu Studio, so that you have exactly what you were looking for where you want it. Again, the major use case on this is face down. Printing things, if you don't mind the texture, the textured PEI surface is phenomenal at hiding those layer lines. Now, with Bambu Studio 174, is that what I'm on right now? 175, which one do I got? 17452, so the release from like yesterday. always turn on developer mode. Developer mode is awesome. It adds all of the stuff that's in Orca Studio is here. Almost every, there's like 5 things that's not in the program. Turning on developer mode makes it all visible. If I come in and look underneath my global settings now, I have a lot of stuff that would not normally show up. Even if you tick the advanced button on, there's going to be other things now showing up by having developer mode on. For example, initial layer flow ratio. If I'm printing signage face down, I'm turning that to 1.05. That tiny little bit extra, is that saying 105% of whatever your material profile says. So if your material profile is 0.98, it's going to be 105% of 0.98. That tiny little bit extra on the first layer helps plug in little holes. It helps cover up any kind of discrepancies you might have, any kind of imperfections you might have inside that model. So if I was printing this face down, flip it over. Oops. Make sure you select everything when you do that, not just one part of it. So let's rotate the whole thing over and slice plate. Come down to the very bottom looking at my first layer. To improve this some, only one wall on first layer. Check the box. That's going to make it a little bit cleaner. I'm going to come up to my my line sizes. My first layer, I'm going to make that as small as I'm comfortable going with a 0.40 nozzle, which is 0.32. Can't go any smaller than that. I mean, you can, but it's not suggested. Smaller lines. Takes longer to print. Finer detail. That finer detail is going to give me a little bit more gap filling. A couple of other things I'm going to change. I'm going to go over to strength, and I'm going to take my wall infill gap and turn that up to 20. It doesn't actually change anything in the preview, but what that's doing, where this infill line prints up against the wall, it's going to be that much snugger up against it, which will help ensure it really closes in. You can play, depending on your model, with either rotating the model on the plate, changing your infill direction if you want. That's purely visual. Just look at it and see which one works best. If you have a lot of elements facing one way or the other, maybe you get better results by rotating things around. I've got 2 walls on my global setting. I'm going to actually turn that up to, well, 2's fine for this. And of course, always 4 top shells. One of the things that I really, really like to do, and you can see right now I've got the one wall, I've got a couple little holes here and here and here. When I go up to my second layer and I have extra walls, I don't know if I can, I can't do it. I wanted to try and keep the mouse where I could like point to a hole. But when I bring that second layer up, I get a wall over where those holes were. So yeah, there's going to be a hole on the first layer, but that wall on the second layer is going to plug those holes in. There's a couple of other things you can change that really, really, really help on this. I always turn off detect narrow internal solid infill. What that does, it looks at it like right here in the M is a great example. It sees that this is a small area, so instead of doing the aligned rectilinear pattern that it would normally do, it turns it to concentric. I turn that off, it's going to force it to use the aligned rectilinear inside of here. Why I care about that? My lines are going this way on this layer. Now my lines are going the other way. It's going to help fill that in. Some areas it just simply can't do that. It's going to draw a thicker line to fill them in. I think Arachne is the default. Did they change it? Change it back to classic. You can switch over to the Arachne engine. That takes a more dynamic approach at the size of lines. The more variety you can get between your first, second, and third layers, the more diversity in how those are printed, the better this is going to look. All of the differences in those layers will overlap where there may have been holes on the previous one, fill it in very nicely. Depending on the colors, the type of material, I typically don't do my embeds more than 0.6, 0.8 millimeters. There's really no need for it. Again, it depends on the material. Like if I'm printing with a translucent or a glow in the dark, which is basically translucent, yeah, those are going to be thicker. Those are going to be 2 millimeters or so. But if I'm putting like red text on a black background or something like that, 3 layers is generally sufficient. Something else to bring up that's new in 1.7, I'm going to say it wrong, 1.75. It's 1.7.4. 1.7.4.5. Yeah, that number keeps throwing me. One of the other things they've changed in here, and this is super, super cool, and it matters. Let's say I'm going to turn on, where is it? I'm going to turn on my skirt if I can find it, or my brim. I'm being dumb and I can't find it. Here we go. I'm going to force a brim, 5 millimeter brim. Now we got lucky. It made it green. They've made this a little bit smarter. It's looking at which one is on the perimeter now. The algorithm originally, and I believe still, looks at the volume of material going down to try and decide which one to print. There was a blurb somewhere saying that they've made it a little bit smarter about looking for perimeter colors. But let's say you are unlucky and you have a model where it decides it wants to print the gray first. And in doing so, you're going to have a green border with a gray brim stuck to it that is going to discolor the edge of your print. You don't want that. Going out a little bit, you've got a couple of options for your plate here. The little hex bolt, they've added this. First layer filament sequence, automatic. Cool. Okay, it worked in this case, but let's say it didn't. I can come into Customize, and I can tell it which order I want it to print my materials in. Now, by telling it Customize and to use my red one first, which this is, we'll get into the numbers in a second. I'm telling it to use my red one first. Okay. Now, if I slice it, I'm probably going to see a red brim. Because what it's going to do when it goes to print this one on the very first layer, it's going to start... Sorry, I was on layer 2. It's going to start with the red, print my brim, put my text down, then fill in everything else, do the other color swaps, move on. Okay. This can be very, very, very useful, even if I'm not using the brim. And I wanted to make sure that the gray went down first, for example. Just, I think, a valid case. I want to make sure that I have these walls printed for my text to come into. Now, I usually do it backwards. I put my text down first. It just depends. I had one earlier today I printed where I wanted to ensure that my white went down first so that when it came back and printed the black that went around it, which would be 2 layers, it would do, because it was only 2 colors on that first layer, I wanted the white to go down first. So it would do 1 layer, my first layer of white, switch to black, fill in the first layer, then immediately do the second layer of black, and then go off to do a color swap. I wanted it to do that because I was only printing a very, very thin part, only 3 layers thick. By doing the 2 black layers and then switching back to white, it would do all of my white with only 1 switch to black before going back to printing more white, which meant if there were any little wispies or hairs that would have been drug from the black printing, I had about 1 minute and 5 seconds while it did the color change to white to pull those off the plate, brush them aside, make sure that I didn't have any of those little hairs in the way that would have gotten embedded in the next white, which would have shown up because it was a light box. It depends on your use. If the automatic color works for you, awesome. If you want to force it to put down a certain color first, you can change that order. This is the first time that the numbers assigned up here actually matter for anything. This has purely been for your reference. I have 1 AMS. I can add all sorts of additional colors in here. The numbers don't matter. That's just for my benefit. If I come over and look at device, you see my 1, 2, 3, 4, it's white, support, green, or glow in the dark, and black. There's no numbers on these. I mean, yes, this is AMS 1, slot 1. And if I were to go and try and print this plate, it's going to ask me, well, what colors do I want to match with? And that's where it tells me that my red, doesn't say 1, it just says red. We're going to match that to A4. And your green, we're going to match to A3. And the PLA, we're going to match, or the gray, we're going to match to A1. This is where your color assignment comes from. the numbers up here are purely for your benefit. Just because it says 1 here does not mean slot 1 in your AMS. If I come through and force this to synchronize with my AMS, of course now I don't have my red, green, blue anymore. It's going to try and print and support W maybe. I don't know. That would be weird. That would be a bad time. Let's make that my green. So it, and we'll make, yeah, okay. So I could print this one now. So now it's got my colors in it that I'd want to use. And if I went to print this, it would immediately match up white to white, green to green, black to black. That's what it's looking at. It's looking at the colors. That's why choosing the right colors in the device tab, in the printer itself, in the handy app, whatever. When you load your filament and you come in and you tell it, oh, this is a generic PLA color white. Cool. You have to try and get this as close to accurate as possible, because this is what it's looking at, is the color. It's not looking at the slot number. It's not looking at, it looks at the material, of course, obviously. If you tell it it's PLA, it's looking to find PLA. But yeah, it's looking at the color. Color also matters in your flushing volumes. The more accurate your colors are to what you're actually doing, which in my case, I've actually gone through and put in the hex values of the materials I'm printing. So if I look at my material profile, the color that's in here is actually the hex values that were given by eSun. So they're white, which I call warm white incorrectly. It's not just 255s across the board. It's not pure white. It's slightly warmer, and this reflects that. That matters because when I come into flushing volumes, it's looking at the color of the material, its density as well, if I'm not mistaken. I think density factors into it, and saying, okay, if I'm going from white to black, I need to purge this much material. If I'm going from black to white, I need to purge a lot more. These numbers are safe. They are probably more than you need. The default multiplier, I don't know if this is a default multiplier. It's been 0.70 for a very, very long time. If I auto-calc it, let's look at this one. It's going to go from 294 to 380. So that's going to absolutely ensure that what comes out of this printer is going to be white and not have any gray left over from the black that was in it before. I don't think, and I'm going to do a learning moment here, if I turn on, where is it? My prime tower, I don't think that makes a change in it. It might. Let's slice it and flushing volumes. Let's find out. If I auto-calc again, instead of 294, it went up to like 380 something. Yeah, it still goes up. You can change this volume. You can leave it the defaults. I like looking at this because it really makes sure, like moving from my support material back to regular PLA, I don't want to have that support material inside my printed model. It'll make it weak. In fact, I had a failed print this morning because of that, because I didn't have my prime tower on. I forgot it like an idiot. Purging all of that out matters. So AutoCalc, okay. Yeah, my material usage is going to go up. I didn't look at the numbers before, but the amount of material just went up for sure because it's purging more. The flushed volume here would go up. So that would definitely change. But I am now guaranteeing a much cleaner print. Now, if you want to get even more into this, giving it that variety, that change between layers to try and fill holes is really important. But sometimes maybe you want to not make it take so long, like the black layer here. Maybe I don't want that to be so ultra fine. I want the white layer to be fine. You can go into the objects themselves and define many variables, not all of them, but many variables. For example, if I wanted to force a wall size just for my white text, I can say my outer walls on this are going to be 0.32 and my inner wall is going to be 0.32. This is now specific only to that one model, in this case my white text. If I come back and look at it, of course I have Arachne turned on, so I don't know if it's actually going to do it. And these are very similar numbers, but you can kind of see where it's a little bit more purple here. That's the 0.32. So it shrunk those walls to make them a little bit smaller. That brings the features closer together, gives me more room to put my infill in. I could do the same thing there. I think I can tell it my sparse infill and solid infill. If I want to make those 3-2. I've made those lines much smaller. They're now going to have more variety as compared to what's on the first layer. It's going to help plug those holes. Always look in your preview. Filament is the default view. That's great. It shows you your usages, some estimates, all sorts of good stuff. Use the other views too. Line type I find extremely helpful because now instead of having all that gray clouding my view, I can see very clearly, oh yeah, there's some gray right here. That means I'm seeing the build plate through it. That's kind of hard to see depending on your colors. Like if you're using a dark color, it's kind of hard to tell that there's some build plate behind there. Switching to line type, I think makes that easier. If you're printing silks, I've got another video talking about speeds and such. Look at the speed to see how fast, how slow it's going. You'll get different speeds on different parts, which means different finishes. Like in this case, you can see there's a slight difference in the speed where my green layer is printing because that hatchbox has a lower volumetric flow rate or a lower maximum volumetric speed. It's a more simple material. I don't know. It doesn't flow as fast, and because of that, it's going to slow it down as compared to what the ESUN is capable of. So this will print slower, which means it'll probably be a tiny bit shinier. Other video covers all the differences on how to actually like look in the G code and find out what the speed is exactly and how to correct for that if you want to. Few other things real quick. I know I'm stretching this one into several different topics. First of all, grid infill is terrible. Don't use grid infill. If I go back to global and strength for this, if I was printing this model, just a little rectangle with some text on it, I'm using aligned rectilinear. It's not the most popular, but it's great. It prints fast. It has no intersecting layers. And if you line it up correctly, you will get very smooth top surfaces with only 3 top walls. And this is where having line type instead of the other one turned on. So you can see here it's printing at a 45-degree angle. And my goal for my top surface is to try and have as small a gap as it prints across as possible. Now, my first top surface layer is considered a bridge because it's bridging across these items. I go up to that next layer. It's going to try and pick the shortest distance between walls, so it's going to be printed this direction. That's pretty decent. In fact, let me hide what's beneath it. That's pretty decent. You can see that red coming through there. Those are fairly small. I can make that better though. If I come down to my infill direction and make that 90, change back to line type so I can actually see what I'm doing. Oh, I went the wrong way. I need to do that. Yeah, I did it the wrong way. 135, or did I just completely? Nope. Let's keep going. 180. It's late. I'm tired. There we go. Now they're going that direction. So if I go back to my line type, now my infill pattern is going to run across this way. Not super strong, but I don't need it to be. There's just a little display piece. When I go up to that bridging layer, now I have perfect 90s across there. That's as short as those can get. With that set up that way, I don't need 4 top surface layers. I can get away with 3. Because those 3 top surface layers are going to cover that up nice and smooth by having really, see, this is what line type. By having, in this case, I guess we'll call it vertical lines, then horizontal, then vertical. It's going to cover it up nicely. Again, I took some strength out of it, but it'll make it print faster and it'll look good on that surface. You can always increase the density if you want to leave that at its default of 45 and say maybe turn the density up to 20. Aligned rectilinear, again, is fast. Because it prints so fast, turning up the density doesn't hurt anything. Sparse infill is 26.7% of this. If I put that back to 15, it's going to be, what, 23% maybe? No, it's still 26%. It didn't even change it. Because that's probably because, no, I changed it to 15. Didn't even change it. It put more line in. It closed those gaps a little bit. But it didn't change the amount of actual material. That's interesting. But now I've got even smaller gaps. Other patterns that I use for a lot of things, support cubic. This one might not be tall enough to actually do anything with it. I don't think it is. No, it's too short. On taller models, this one's great. It aggressively hollows out the infill and then builds it back up for your top surface. It does have intersecting lines, though. So if you're printing TPU, PETG, things like that, it'll probably mess it up pretty gnarly. If you're printing fast, it'll have problems with some PLAs. Speaking of speed, one other thing you can do here, and this is something I almost always change just to save time, and I've not yet had bad effects from it. You see, we've got roughly in the 200s here where it's printing all of this, but when I go up to that bridging layer, it's going to be really slow. It's going to be like 50, 60, somewhere in there. That bridging layer, if I look under speed, yeah, 50. Well, that's no good. I want to print that faster. In fact, I'm going to print that the same speed as my outer wall. I'm going to give that 200. Now, it's not actually going to be 200, I don't think. I think it's going to be a little bit slower than that. Go to speed. It might be 200. Now I'm curious. Now I want to know. Go to the start of the infill. Yeah, that's 200 actually. Okay. Cool. So it's actually doing 200. I thought it was going to be a little bit slower. This prints fine. I have no reason to not want this to print at speed. Not with PLA at least. With some other materials, maybe you do want that a little bit slower. PETG is sticky and it doesn't like bridging, so maybe, at least in my experience, other people are smarter with PETG than me. I usually turn this up. It cuts a lot of time off the print because that's a lot of material going down to be printing at a slow speed. We're looking at an hour and 17 minutes total time, and our bridging layer, that's more than a minute. It's not recording that properly as a bridge. That would be part of... See, it has the color code for bridge, but I know it's not bridge. Actually, this is a small part. It might be 1 minute. If I switch that back, let's see what happens. From an hour 17 to an hour 19. Okay, so again, small part. You can imagine, though, on a much larger part, if I were to blow this up, how much time that could be. And yeah, okay, so it does report it as a bridge. I apologize. Very small part, though. I mean, this thing's only like 35 by 100 millimeters or whatever. It's not big. That bridging layer prints so slow. And I have printed them at speed before, and they come out just fine. Make sure your infill pattern beneath it is going to give it small gaps to bridge. Print it fast, you're fine. If you start to see pillowing, where it looks like there's tears in that bridging layer, you can turn the speed down a little bit. And the easiest way to make sure that your top surface looks better is to just throw another top shell wall in, or top surface wall. What do they call it in here? Top shell layer. Your entire purpose of this is to try and get as much material as is necessary in order to give you a smooth top finish. Lining the infill up, usually I can do it in 3. Sometimes I do it in 4, at least when we're talking 0.2 millimeter layers. If you're printing smaller layers like 1.2 millimeter or 0.08 or something like that, you need more. Turn it up some. You need that volume of material there. In fact, I'd say when I'm printing in 0.12 layers, I usually have like 6 or 7, just to make sure that it actually gives a nice clean surface. You can turn on ironing, but ironing doesn't solve an unlevel surface. In fact, ironing on a surface that is not level, that is not nice and smooth, it'll make it worse. As it goes through to do the ironing pass, I think that's under quality, yeah, top surface, whatever, do it. If I come up here and look at it from this view, line type, now I've got this kind of like peach color on it. That's my ironing. Ironing is slow, but that's on purpose. It picks a different direction. If I turn off there, and you can see that I've got the 45-degree angle on my top surface here. The ironing is going to come in. If I zoom in a lot, it's going to go in a different direction. And ironing actually puts out just a tiny little bit of material. Just a very, very little bit of material. If this surface is not level, it's going to run into little sags, little valleys in between where the infill walls were. And it's going to kind of pill up. And then it gets to a high point where that infill line was underneath, and it'll look good. And then it'll go back into the next little valley. And you end up with a very inconsistent surface. So you want to make sure that you have as smooth and level a surface as possible before you turn ironing on. And if you're getting really ugly results from ironing, I don't change these settings. I don't make it faster. I don't change the flow ratio. I don't change these things. I've never had a need to. I make sure that my top surface is smooth. Add an extra wall, increase the infill density, change its orientation, do those things, and ironing will come out perfectly smooth. I mean, I've got almost mirror-like results on top surface layers. So I know we kind of rambled there. I hope this is informative and gives you all sorts of good information. Happy printing.